All right, so we're going to work through an example of a free response question that involves z-scores and the normal model. So, a forester measured 27 trees in large woods that are up for sale. He found a mean diameter of 10.4 inches and standard deviation of 4.7 inches. Suppose that these trees provide an accurate description of the whole forest and that a normal model applies. So, step one, draw the normal model. So, I have a scratch paper here. I'm going to draw the normal model since I don't like to on here. But, normal model is very easy. It's a bell curve, so it goes up and down like that. Doesn't have to be super accurate. But it is important to label your axes, right? So we know our mean is going to be here at, 10.4 inches. So there we go. So 10.4 inches. Yes, you need to write inches. We know our standard deviation is 4.7 inches. So say that's about 4.7, 4.7, 4.7. 1, 2, 3. I know it's uneven. I'm sorry. I'm trying my best. So this would be, all right, calculator, save me. Let's see, 10.4 plus 4.7. So this would be 15.1 inches plus 4.7. 19.8 inches plus 4.7. 3 standard deviations out, 24.5 inches. That's pretty big. And then the other way, yes, you have to do the other way. When answering these questions, if you're ever in doubt, if you need to, like if you really need to, chances are you do, right? Okay. 5.7 inches. Oh, come on, Poulter. It's a nice round number, 1 inch. And then it's obvious that we're not going to go into negatives, but I'm going to write it anyway. So, negative 3.7 inches. All right. Obviously it's impossible for you to have less than 0 inches of diameter because it's a measure of distance, but, for the sake of the problem, we're going to do it. All right. Okay. Get out of here, calculator. Okay, so we've drawn the normal model. This is the normal model. This is tree diameter in inches. There you go. Easy. Part B. What size would you expect the central 95% of all trees to be? So this is why it's a good idea to go through and do this. So 95% is 2 standard deviations. Remember our, what do we call it? It's the 68, 95, 99.7 rule, empirical rule. So it's the empirical rule. We can say, okay, here, I'm going to make my font really small. There we go. Because the trees follow a normal model, we can use the rule to, spelling is key, kids, mate that the diameters of the central 95% of trees to be between 1 inch and 19.8 inches inches. We already said diameter. You don't need to be redundant. All right, now there you go. There's part B. And that, based on our diagram, that makes sense, right? I know 4.7, that's a large standard deviation for this, but whatever. So yeah, so that would be this area here, right? So it makes sense. I mean, yeah, it's a wide range, but based on the data we got, kid only collected 27 trees. What are we going to do, right? We'll talk about how 27 may not be a decent enough sample size for this. Whatever. It's his fault. It's not ours. All right, part C. About what percent of the trees should be less than 1 inch? So again, we have our normal model here. Less than 1 inch is less than this 2 standard deviations. So one way you could do it, based on the empirical rule, we know that this would be a central 95%, which means this tail here plus this tail here should add up to 5%, and they should also be evenly split, right? That means that this is half of 5%, or in other words, 2.5%. So again, because we are assuming the trees provide an accurate description of the whole forest, and the normal, that's not how you spell that, all applies. We can use the empirical rule again. I can't spell. Saved my life. There's a reason I teach math. My English teacher parents would be disappointed. Both my parents are English teachers, so they're crying right now somewhere. There's definitely an R in normal in there. We can use an empirical rule again to show that 2.5% of trees are here, I'm going to edit this. We can expect. There we go. And when you're doing this, I would definitely sketch this graph again and shade that area and use, you know, the symbol here. Not symbol, sorry. Use this visual here to say, oh, well, here's 95%. Here's 2 standard deviations. That's got to be half of 5%, right? If you forgot the empirical rule, which is possible, you could do this one of 2 ways. The first way is you could get your, well, first you can calculate the z-score for 1 inch based on this. So we have 1 minus 10.4. This is part C, right? 1 minus 10.4 over a standard deviation of 4.7. And our trusty calculator tells us that that is equal to, I don't feel like doing it in my head, and don't lie, you're not doing it in your head either. -2. So if we had forgotten our empirical rule, maybe this would be, you know, a red flag. Hey, you're about to do too much work. But let's just say that we like doing too much work and we want to use a table anyway, because reasons. So we get our table and we say, all right, well, my z-score of -2, that's right there. It's a little lower than I would have expected, but there's the z-score for -2. So this area in this graph here would be 0.228. So we could say, all right, and again, based on a z-score of -2, which yields a p-value of 0.0228, we can expect 2.28, if you're going to do it this way, percent of the trees to be less than 1 inch in diameter. All right, there you go. Another way to do it, which I'll show on part D, because again, you can do the same thing here with 5.7 and 10.4 inches. That would be half of the 68, but I also want to show, actually this should be pretty straightforward. Here, I'm going to let you work out part D, see if you can figure that out. I'm going to pause the video, or I'm going to pause the recording. You figure out part D. I say I'm going to pause the video. You pause the video. I can't pause the video from your end, but pause the video, see if you can figure out part D on your own. There you go. There's your answer for D. Hopefully you got it right. Yes, I would word it pretty much like that, and I would also sketch this picture to go along with it. Sorry, I don't know why I pointed at my screen. You can't see me pointing at my screen. I would put this picture somewhere in this area if I were going to answer that question. Now, last but not least, I'm sorry this is taking so long. Part E. About what percent of the trees should be 15 inches or over 15 inches in diameter? We see that that's not quite where our line lines up for our standard deviation. We could approximate, but let's say we're a bit nitpicky. We want to be very precise in our calculations. So what we have here on our calculator are the tools that I showed you in the last video. Pardon me. So what we can do is say, all right, well, I know this is normal. And I know I'm looking for a cumulative range underneath the graph. So I can say, all right, statistics, distributions. This is a normal CDF situation. I know my lower bound is going to be my z-score because I want to know what is over 15 inches. So I'll say, okay, over 15 inches. And then my upper bound is, super big trees, right? Like unrealistically large trees. Our mean, in this case, is 10.4 inches, and our standard deviation was 4.7 inches. And this will tell us that we can expect 16.3% of our trees to be in that range. So to write that out, here, I'll give you a second. There's a correct numerical answer. See if you can write out or scribble out an answer that would be acceptable by College Board standards. All right, and there you go. There's my answer. Since the data is assumed to be from a normal distribution, we can use the normal CDF with a lower bound of 15 inches and an upper bound of infinity, a mean of 10.4 inches, and a standard deviation of 4.7 inches. This yields a p-value of 0.163858, or you want to round to the second decimal place usually, 0.1639, suggesting that about 16.39% of the trees should be over 15 inches in diameter. And that, my friends, is basically all the ways you can think of, or all the different methods you can use. Use your empirical rule, use your tables, or you can use your calculator to answer these free response questions. All of these methods would have been acceptable. You could have done all of these in the calculator if you really wanted to. But yeah, hope this was helpful.